EVN routing with RIP version 2. In this video, I am going to show you how we can configure routing protocols such as the RIP version 2 in the EVN. It's similar to the configuration of the routing protocols in the VRF Lite feature, but I'm going to show you the configuration of the RIP version 2 in this video, and in the future videos I'm going to show you how you can configure the EVN routing with other routing protocols. First, we should configure the EVN in this scenario with one notepad file, and after that we can configure the RIP version 2. Let me to start with the configuration of the router 1. Here is the router 1's configuration. You know that by default, or at the first, we should configure the VRFs in the router 1. Here we have 3 VRF, VRF-A, VRF-B, and also VRF-C. Let me to configure this VRF. It's so easy. VRF definition A. This is the first VRF. We can use the VNet tag between 2 to 4094. For example, for the VRF-A, I'm using the VNet tag 2, and also we should enable address family IPv4 unicast for this VRF. It's so easy. After that, I'm going to copy the VRF definition A for VRF definition B and also C. Now we have 3 VRF, VRF-A, VRF-B, and VRF-C. We should use this unique tag for every VRF. For example, for VRF-B, I'm using the VNet tag 3, and also for the VRF-C, I'm using the VNet tag 4. 2, 3, 4. Don't forget that the VNet tag should be same between the router R1 and router R2, okay? After that, we should assign these VRFs to the interfaces of the router 1. For example, here we have 3 interfaces: ETH00, ETH01, and ETH02. Interface ETH00 with VRF with this command can be assigned to the VRF, for example, a VRF forwarding A. That's it. Also, we should configure one IP address. The IP address, as you can see here, is 10.1.0.1, 10.1.0.1, 255, 255, 2550, and then no shutdown. Again, we should configure interface ETH01 and ETH02. Interface ETH01, interface ETH02, interface ETH01 is a member of the VRF-B, and interface ETH02 is a member of VRF-C. Also, the IP addresses of these 3 interfaces are same. Because of that, I'm using the 10.1.0.1 for these 3 interface, and this is the configuration of the interfaces ETH00, 01, and 02. Now we should configure the ETH03 interface ETH03. We need only one command: VNet trunk, and that's it. Then we should configure IP address. The IP address is 10.1.2.1.255.255.255.0. No shutdown, very easy, okay? And after that, we should configure the similar configuration in the router 2. Let me to copy the configuration of the router 1 and change. With some change, we can apply it to the router 2. Now this is the copy of the router 1's configuration, then router 2. Also, don't forget, you can configure the host name in R1 to R1. Host name R1. Okay, let's go to the R2. The host name is R2, first command, and then we should configure 3 VRF. The VRF name can be different, but VNet tag should be same between the R1 and R2. Okay, and then for example, we should assign these VRFs to the ETH00, ETH01, and ETH02. As you can see here, the IP address of these 3 interfaces are same: 10.2.0.2, 10.2.0.2. If you want, you can use another IP addresses, but here I'm using the same IP address because I'm going to show you that you can configure 3 interfaces with same IP address, because these 3 interfaces are members of 3 virtual router. Okay, and now we have the interface ETH03 with the VNet trunk command, and the IP address of this interface is 10.1.2.2. That's it. This is the initial configuration of the EVN. But after that, we should configure the RIP first. let me copy this configuration into the R1 CLI and R2 CLI, and after that we can configure RIP version 2. In R1, this is the CLI of R1. Let me to copy this configuration. As you can see, I didn't receive any error message. Very good. And after that, in R2, I'm going to copy the configuration and pasting this configuration into the router 2 CLI. Very good. First, let me check the configuration until now, and after that, I'm going to configure the RIP version 2. From R1, show IP route VRF, you can use show IP VRF. Show IP VRF, we have 3 VRF, and the interfaces of these 3 VRF are ETH00, ETH01, and ETH02 for the LAN side, and for the trunk link, VNet trunk link, we have ETH03.2, 03.3, and 03.4. And after that, if you want, you can check the show IP route for VRFA. We have 2 connected networks, VRFB, 2 connected networks, VRFC, 2 connected networks. So easy. And after that, in the router 2, okay, in the router 2, we can check again show IP VRF, for example. And as you can see there, the result is similar with the router 1. Also, we can check the show IP route, VRFA, VRFB, and VRFC, okay? Only the connected networks now are available in the routing table of the 3 VRFs. You know that in router R1 now we have 3 routers, 3 VRFs, and also in router R2. Now, I'm going to configure the RIP version 2. It's similar to the configuration of RIP in VRF Lite environment, but I'm going to show you how you can configure it again here. In RIP version 2, you can configure the RIP for every VRF. For example, I'm using this syntax, router config. You know that for configuring the RIP version 2, we should use the router RIP command, and then we will go to the router config router, and after that we should change the version to 2 because the default version is 1, version 2 is the next command. After that, router config, okay, router, the command is for example address family IPv4 unicast for VRF name. After that, we will go to the router config router AF, and here we should enable the RIP on the interfaces that we want. Network, for example, net ID. You know that here we should configure the classful network ID. Okay, let me to show you. First, for VRFA, I'm going to configure the RIP in R1. Okay, conft router RIP. Then version is 2, for example. After that, address family IPv4 unicast for VRFA using this command, network 10.0.0.0. That's it. And then you can configure no auto summary if you want. And also in R2, let me configure the R2 in RIP version 2 only for VRFA. Router RIP version 2, and then you can use this command, for example, address family IPv4 unicast VRFA. Okay, then network 10.0.0.0, and after that no auto summary. Let me to show you the routing table of the VRFA. Do in router R1 do show IP route VRFA. As you can see in VRFA, now we have 10.200/24 received from the ETH03.2. This is the next hop IP address of, this is the next hop interface, and this is the IP the interface of the router 1 that received this update, and the 10.122 is the next hop IP address. So easy. And in R2 also we can check do show IP route VRFA. Look at here. In VRF we received the route from the router R1 VRFA, but in VRFB we didn't configure the RIP. Let me show you. Do show IP route VRFB. Okay, we have only connected networks. And also in router 2 do show IP route VRFB, and also we received only we have only connected networks. If you want to continue the configuring the RIP, you should enable the RIP in the address family IPv4 for VRFB. Okay, let me to show you. In R1 I'm going to address family IPv4 unicast VRFB. Again we should configure network 10.0.0.0 and with the no to summary. And after that in R2 exit address family IPv4 unicast for VRFB. Okay, network 10.0.0.0 independent routings. Okay, no auto summary. Now we can check in R1 do show IP route for VRFB. Now we receive 10.2.0.0 in the VRFB these networks, and also in router 2 do show IP route VRFB, for example. As you can see, we receive the routes from the router 1. And finally, in the VRFC, now in VRFC, we don't have the RIP routes. Because of that, we should configure address family IPv4 unicast for VRFC network 10.0.0.0. No auto summary. And after that, in router 2, I'm going to configure in the address family VRFC address family IPv4 unicast VRFC network, okay, 10.0.0.0, and finally no auto summary. Now we can check all the routing tables in R1. Do show IP route VRFA. This is the do show IP route VRFA. This is the routing table of VRFA, and we receive 10.2.0.0 over the ETH 03.2, the sub interface of the, for example, VRFA, and also VRFB. In VRFB, we receive 10.2.0.0 from the ETH 03.3, and do show IP route VRFC, we receive 10.2.0.0. Finally, in router 2, look at here, show IP route VRFA, we receive the 10.1.0.0. Show IP route VRFB, and again we receive the 10.1.0.0, and finally show IP route VRFC, we receive 10.1.0.0. Now we can check the connectivity between VPC1, VPC2, VPC3, VPC4, 5, and 6. For VPC1, the IP is 10.1.0.10, 24 is the mask, and gateway is 10.1.0.1. For VPC2, the same IP address, 10.1.0.10, 24, 10.1.0.1. And also in the VPC3, the IP is 10.1.0.10 with the mask of 24, the gateway is 10.1.0.1. In VPC4, the IP is 10.2.0.10, the mask is 24, and the gateway is 10.2.0.2. In the VPC5, okay, this is the VPC5. Let me to show you. The IP is 10.2. In VPC4, I'm using the 10.2.0.11. Let me to change it. In VPC4, the IP is 10.2.0.11. It's okay. And in VPC5, okay, in VPC5, I'm using 10.2.0.12 with the mask of 24, 10.2.0.2, the gateway. And finally, in the VPC6, this is the VPC6 here, IP is 10.2.0.13 with the mask of 24, gateway is 10.2.0.2. That's it. And after that, we can check the connectivities from VPC1. Let me to show you ping 10.2.0.11, the IP address of the VPC4. We have connectivity. If you want, we can check the trace route 10.2.0.11 from the, for example, VPC1, 10.1.0.1, 10.1.2.2, and finally 10.2.0.11. Okay. After that, from VPC3, we can check the ping 10.2.0.12. Yes, we have connectivity. And from the VPC3, we can check the connectivity with the 10.2.0.13. Yes, we have connectivity. Don't forget, for example, from VPC3, this PC, I can't ping the 10.2.0.12 because you know that 10.2.0.12 is reside on another network and another virtual networks. Okay, so easy. Very good. Also, don't forget, if you want, you can use the routing context. Look at here. Here from router R1, okay, same as the VRF Lite. You know that, for example, in R1, if you want to check the connectivity with the connected networks, you should use the ping VRFA, okay, then 10.1.0.10, okay, ping in VRFA 10.1.0.10. Or you can use ping in VRFB, means in from router B, virtual router B, 10.1.0.10. This is the second router. Or assume that, for example, in R1, you can use ping VRFA, from VRFA, the IP address of the VPC for 10.2.0.11. Okay, we have connectivity. Okay, but we don't have connectivity to the 10.2.0.12 because you know that 10.2.0.12 is reside in the VRF in another VRFB. Okay. You know that if you want to check the connectivity, for example, ping command, traceroute command, or other command, telnet command, you should use the VRF keyword for all of these commands. For example, if you want to trace from this PC in the VRFB 10.2.0.12, okay, you should use the traceroute VRFB 10.2.0.12, okay. And for every command in R1, you should use the VRF keyword because you should define the VRF that the function should occur from that VRF. And this is necessary to give the router the VRF name. If you don't give the router the VRF name, router should check the global routing table, okay? And then, if you want, you can use routing context. Routing context is a new feature. Routing context, for example, VRFA. The means of this command is that now you reside in the VRF router. Okay, as you can see, now I'm reside in the VRFA, and I can use the, for example, ping without using the VRF keyword. Ping 10.1.0.10. That's it. I have connectivity. Ping 10.2.0.11. Okay, I have connectivity. Traceroute, for example, 10.2.0.11. Look at here. I didn't use the VRF keyword. Why? Because now I am residing in the VRFA. Okay. If you have many tasks that you should do for a VRF, for example, VRFA, it's easier to using the routing context. You can go to the routing context of the VRFA or other VRFs and using your commands. And after finishing your commands, you can exit this VRF and from this routing context and continue the other functions from the global routing table. Very good. This is the configuration of routing with RIP version 2 in the, for example, EVN. As you saw, the configuration of RIP is exactly similar between the EVN and also VRF Lite.